Good morning, my Year 10 students. I'm here again to present to you a presentation about waves, general properties, and problem solving. This is Miss Teresa. Okay, so our lesson objective for today is to describe general wave characteristics or properties. It's the same as yesterday. And our success criteria is I can use my knowledge of general wave properties to answer questions and solve problems using V is equal to F lambda. Okay, yesterday we learned about these words, wavelength, okay, which is measured in meters, okay, wavelength. And it's denoted by the symbol lambda. Okay, wavelength is the distance covered by a full cycle of a wave, usually measured from peak to peak or trough to trough. Frequency, it's the number of waves passing a point each second, and it's measured in hertz. The symbol is F. Amplitude is the maximum displacement of a point of a wave from its rest position. It's also measured. It's measured in meters also. And amplitude, the symbol is A. Period is measured in seconds. It's also called time period by other books. Okay, the time taken for a full cycle of a wave, usually measured from peak to peak or trough to trough. So that's period. And the symbol is big letter T, not small letter t, because small letter t is for time only, ordinary time, that is. And crest, this is not a quantity, it's just a part of a wave. And trough, the highest part of a wave, the lowest part of a wave. Okay, so all of those are the things that we learned yesterday. But frequency is equal to 1 by t period, and t is equal to 1 by f. They are reciprocal to each other. And what else? What's the difference between frequency and time period? If we say frequency of 50 hertz, what does it mean? 50 complete waves passing through a point in 1 second. That's what it means. Whereas if we talk about period, this one complete wave, how much time did it take? That's the period of the wave. Okay, so any more questions about this, you have to just send me a message in the private chat part of our Teams. Okay, so that's all. Amplitude. Okay, I think that's all. Now, if I forgot something, just remind me also. So what I forgot actually yesterday is wavefront. So remember our ripple. Yesterday I talked about ripple. You throw a stone or a pebble on a very calm lake and ripples will form from the source of the disturbance of the water, and it will go outwards. Now, this line represents a wavefront. This is called wavefront. So what do we mean by wavefront actually? If we have a series of identical waves formed on water, okay, and if we are going to draw a line on top of that, or we are going to connect all the crests of that wave, those identical waves, that is called the wavefront. Okay, that is wavefront. I don't know the significance of it. I didn't see any question regarding wavefront last year, but just in case you need that knowledge, then okay, that's additional knowledge for you. Okay, moving on. Now we're going to test our knowledge whether we really understood our lesson yesterday. This is one question. The amplitude, frequency, and wavelength of a sound wave can each either be increased or decreased because they are quantities. So, what change or changes would you do to make the sound quieter? Yesterday I talked about loud sound and soft sound, and what quantity was that? Was it amplitude? Was it frequency? Was it wavelength? So I think that was about amplitude. The higher the amplitude, the louder the sound. The lower the amplitude, the quieter the sound or the softer the sound. So what change or changes would you make to would you do to make the sound quieter? Okay, we're going to change its amplitude. We are going to lower its amplitude. Okay, you have to write this in words. Do not answer like this because they will not give you 1 mark for it. Okay, what change or changes would you make the sound? Would make the sound higher in pitch. Pitch, I talked about pitch yesterday and I gave 2 examples, and that was about frequency. More frequency, that is higher in pitch, and lower frequency, that means lower in pitch. So how could we make the pitch higher? We are going to increase what? Frequency. So that's the answer. Okay, so if you have any question, just send me a message in private chat. Now this case, I think you can answer this on your own. Okay, I'll just count for you. So how many waves are here? So here, the higher amplitude, 1, 2. And the lower amplitude also 1 and 2. So as you can see, they have the same number of complete waves. And what's different in them? Okay, you can clearly see. So I think you can answer this on your own. I will not give you the complete answer for that. Next. This is a little bit, it's actually easy. We gave this question last year to our year 7 students as an introduction to sound. Okay, so let's count in here. Now, let's see first which one have the highest frequency. Let's count. 1, 2 hertz for this. 2. How about this one? It's 1 and something like a half. So this is 1.5 approximately. How about this? 1, 2, 3, and 4. This is 4 hertz. How about this one? 1, 2 and a half, 2.5 hertz. And how about this? 1, 2 and a half, also 2.5. So if the question is which ones have the same frequency, then you would already know what the answer is. Which one has the same amplitude? Then I think you'll also know what that is. The height. If the heights are the same, then they'll have the same amplitudes. If the number of waves are the same, then they have the same frequency. Okay, so I'm not going to answer fully. You're going to write the answers in your notebook. If you want to copy the diagrams, that's also very good so that you won't forget. Okay, moving on. Next. Okay, this is similar to the previous page. Then, okay, let me answer the previous page. Okay, let's go to this. I'm gonna answer. Which 3 diagrams show traces with the same amplitude? Okay, so the answer will be A, B, and C because they have the same heights. And which 2 diagrams show traces with the same frequency? Where was it earlier? I forgot. 1, 2.5, 1, 2.5. It will be D and E. Yeah, D, not P. Okay, wait, sorry. D and E. Am I correct? Please tell me. This is 1, 2. This is 1 and it's not completely 2.5. Yeah, this is 1.5. This is 1, 2, 3, and 4. I forgot. Sorry, I'm counting again. 1, 2.5 and 1, 2.5. So D and E, I'm correct. Okay, so that's the answer for this page. Now, since I answered this, I'm requiring you to answer this page, this slide in your notebook. Okay? I think I need to require you to copy the diagrams for this. Anyway, it's easy to draw. If you are lazy in copying if you're lazy in copying the diagram, then okay, print this page. I sent you the PPT. Be sure to print it as not as a slide but as a handout, because if you print it as a slide, it will print the whole page in one A4 sheet, and that's like a very big a very big diagram for you to stick in your notebook. Just print it as a handout, and it will give you small what is this, images in, I think in an A4 sheet it could give you four images of a slide. Okay, so that would be more convenient for you to stick in your notebook. So you answer this page in your notebook now. Okay, so next page. So similar, it's a similar question. It says 4 different sound wave patterns are shown. They are all drawn to the same scale. And which sound wave pattern has the highest pitch? Give a reason. This time it will ask you to give a reason. 1 mark for this, 1 mark for this, for the reason. Which sound wave pattern is the loudest? 1 mark and 1 mark. So it's just asking you about your knowledge of frequency and amplitude. So you answer this also in your notebook. It's quite easy. You have to practice giving your answer, giving a reason for your answer though. Okay, so moving on. Next page. This is a little bit more technical than the others. So let's say that this is water wave. So it says there in your question is a water wave. Now this is the rest position. This is the highest point where it can reach, and this is the highest lowest point it can reach. Now it says -3 here. It doesn't mean that it has a negative value. It's just telling you the direction of the wave. It's below the rest position, therefore it's a negative sign. This is above the rest position, that's why it's a positive sign. It doesn't mean that this has a lesser value than the 3 above. No, it means that they have the same values, only their directions are different. Okay, so that's the highest and lowest point of the wave. Now what's the amplitude? Okay, how about wavelength? So we can measure wavelength from peak to peak, rest position. We can also measure the wavelength from trough to trough, or from this point to this point. Okay, now how about frequency? How can we measure frequency? Now earlier I gave you, like, let's look at the other waves. So all of these waves, they're all starting like at this point, so it's easy to count. That's 1 wave, 2 waves, 1 waves, 2 waves. But how about if our wave starts at this point? What is 1 wave? 1 complete wave. So 1 complete wave in this case will be 1. Okay, and then 2, and then 3. Yes, 1, 2, 3. 3 V's, 3 complete V's. So this is 3 hertz in this case. Okay, so how about if the wave, let's say, doesn't start here? It starts, let's say this is not there. It starts here instead. It starts here. So what's 1 complete wave? It will be 1 complete wave. So this is the second one, and this is half. So this is 2.5 in this case. Okay, how about if it starts here? Yeah, that's the basic thing that I told you already. That's easy to count. So you have to be sure where your wave started. So if it starts here, it also ends here. That's 1 wave. Okay, if it starts here, it also ends here, then that's 1 wave. So be mindful of where the wave started also on your grid. So in here, let's say, because it didn't say how much time it took for this wave to be completed. Now let's say that this, how many waves? 1, 2, and 3 waves was completed in 0.02 seconds. So what's the frequency of this wave? Okay, so how do we solve that? frequency of this wave? We know that frequency is measured in hertz. And hertz also means 1 by second. So if this, how many waves? 1, 2, 3 waves was completed in 0.02 seconds, what is the frequency? How to calculate that? Okay, let me calculate for you. It will be 3 waves. 3.02. So in this case, the frequency will be, okay, 3 complete waves in 0.02 seconds is frequency is equal to 150 hertz. What does it mean? Okay, it means that in 1 second there will be 150 complete waves passing through a point. Okay, but what is the period of this wave then? If 3 waves is completed in 0.02 seconds, what is the time period of this wave? What does it mean, time period? How much time does it take for this to complete one wave? That's time period. So the time period here will be 0.0067 seconds. It means that from here to here, completed one wave, that's 0.0067 seconds. 0.006067 seconds. 67. Okay, seconds. So how did I get that? It's just that T is equal to 1 by F and F is equal to 1 by T. Once you solve for the frequency, you just get the reciprocal and you'll get the period of one wave. So if I'm wrong, please hit me up in the private chat, okay? Correct me if I'm wrong. I'm not saying I'm right all the time. Yeah, 99% of the time maybe. Okay, so let's move on. Next. Okay, it's actually the same graph, just that you have to answer these questions. And again, you should know, I will not answer it for you. You're going to copy these questions, print this or draw this on your notebook, then answer the questions. This time it's necessary for you to copy the questions because you might be needing it for revision later on in your life. Okay, so I'll move on to the next. It's the same one, similar one. It's not the same, it's similar one. Figure 4 shows the graph of the sound made by a tuning fork in an oscilloscope. What is an oscilloscope? Please research about oscilloscope. It is a device actually. I will not tell you more about it because you need to research about it. Okay, so each horizontal division in figure 4 represents time of 0.0005 seconds. So each line here from here to here is 0.0005 and it continues that way. Now, what is the frequency of the tuning fork? So again, I will not solve this for you. You're going to solve it in your notebook. I'm going to discuss the answer in class after you solve this. Okay, because we have like a lot of time today, so we'll have time to discuss about this question. You give me the answer, and then I'll ask you later one by one, anyone from the class, and I will ask you what's the frequency of the tuning fork, okay, of the slide number 12. Okay, so solve for that. Similar problem from the previous one, so it should be easy. Okay, it's just that now you're being given that each square is 0.005 seconds. So one complete wave will be this, and then this is the other complete wave. Is this 1 second? I don't think so. Maybe because each grid is like 0.005 second. Just one tip though, okay, just count the number of squares over here, multiply it to 0.005, then you would know the time over here. Okay, let's move on. Okay, this one. Maybe I'll try to answer this for you. Okay, and here it says that from this point to that point is 0.001 second. How many waves are produced by the loudspeaker in 0.001 seconds? So look at that. It didn't start at the rest position. It also didn't start at the top. It started at the rest position itself here on halfway through one curve. So we're going to count one, that's one wave, two, and no, let me see because I have to make it bigger. Wait, this is too tiny. Okay, make it bigger. Okay, let's count. So it starts here and it ends here. How many waves are there? So 1, 2, 3. Okay, so in 0.01 seconds, how many waves were produced? So in this case, there are 3 waves produced. I think I'm correct. Okay, so how many waves are produced by the loudspeaker every second? Every second. So this is 3 waves in 0.0001 second. How about in 1 second? Assume that the input to the loudspeaker that does not change, because loudspeakers actually change the frequency of a sound. It will make it like more, no, less, and then the amplitude also will change. It will make it louder. Now assume that it won't change. What is the, how many waves? It's asking you about frequency. The second question is asking you about frequency. So how are you going to solve this to change it into frequency? We already solved something like that in the previous slide. So please solve this by yourself so that and then tell me the answer afterwards. In class, I will ask you, and also write this in your notebook. Okay, thank you. Let's go on to the next slide. Okay, this is a V is equal to F lambda type of question. We know that V is equal to F lambda. How do we know that this is the correct formula? It's there in your success criteria. Okay, so this is the speed of an ultrasound wave in a soft tissue in the human body is 1.5 into 10 raised to 3 meter per second. Okay, so now how do you know which quantity is this? It's in meter per second, so this is V. The frequency of the wave is 2.0 into 10 raised to 6 hertz. How do you know that this is frequency? It is said plus the SI unit is hertz. So now we are going to calculate for the wavelength. So this is your formula. V is equal to F lambda. How are we going to calculate for the wavelength? So in this case, wavelength is equal to V by F. Am I correct? Lambda is equal to V by F. Okay, correct. So in this case, V is 1.5 into 10 raised to 3. So I'm going to calculate 1. That's 1,500 if it's 1.5 times 10 raised to 3. Divided by the frequency, which is 2.0 into 10 raised to 6, divided by 2.0 into 10 raised to 6. Okay, so is equal to 0.00075. So that is actually wavelength is 7.5 into 10 raised to 4, negative 4 meters. So it's negative 4. Now I don't need to write the SI unit because it's given there. That's why it's only 2 marks, because 1 mark for your solutions, your working, and 1 mark for this answer. If it's 3 marks, it means that they are going to check your SI unit too. But in this case, it's only 2 marks. So if it's high frequency, I think this is a high frequency. Yeah, it is a high frequency wave. So what does it mean if it's high frequency? Okay, let me just clear this up. So, oh wait, this is the answer. Okay, if I'm wrong, just hit me up in the Teams chat. Okay, so in this case, it's a high frequency. So if it's a high frequency, it means that they are tiny and they need to be very tiny because they need to be completed in one second only. So as you can see, the wavelengths are very small compared to a very big wave. The wavelength will be very big. This is the wavelength, but in this case, if it is a high frequency, if it's a high frequency wave, then consequently the wavelength will be very tiny. That's why that's 7.5. Yeah, I forgot the answer. It's 10 raised to negative 4. The multiplier is 10 raised to negative 4. So that is the consequence of being a high frequency sound. The wavelength will be very small. If it's a low frequency sound and it's like this, then the wavelength will be very big, large, like water waves. In this case, if it is a sound wave or an ultrasound, then the wavelength will be very tiny. Okay, so that's it. Now let's go to the next slide. This is a question for you to do. Okay, I've already shown you how to solve this, so everything will be just this one, v is equal to f lambda. So in this case, you have to be very careful only because look at this, it's 4 marks. Why is it 4 marks? Because this form, oh wait, sorry, where is it now? Okay, this formula is already given to you. So why is it 4 marks? Okay, because you're going to change this into meters. 1 mark for that. And then you're going to solve something using v is equal to f lambda. Okay, that's 1 mark. And then you're going to explain how does the speed of these water waves compare to the typical speed of a person walking. That's 2 marks. Okay, because this is related to everyday situation. Usually if they ask a question related to everyday situation, the explanation there will be 2 marks. So 1 mark for the conversion, 1 mark for the problem solving using the v is equal to f lambda. It's only 1 mark because the formula is already given to you, and 2 marks for the explanation of this everyday situation application. Okay, so you're just going to compare water wave. Is it faster than how a normal person walks? If you are an athlete who excels in walkathon, maybe, I don't know, you have to solve it and then compare. Is it faster or similar to or slower than a typical person walking? Okay, so that's why it's 4 marks. Always look before you solve something, always look at the marks. Why? Because you might be already solving things or busy copying the answer of your classmate and you don't realize that you're being marked for such things. There's a reason why you're being given 4 marks, 3 marks, 2 marks in such question, in some questions. Okay, so be careful. Now I want you to answer this also in your notebook. Okay, this, of course, you will also answer it in your notebook. This is just v is equal to f lambda application, so it's only 2 marks. Okay, you already know the answer to that because the formula is not given. 1 mark for the formula and 1 mark for the answer here. SI unit will not be marked because it's already given. So answer this also in your notebook. Be mindful all the time of the marks. You should always look at the marks. Do you understand? Okay, moving on. Also this one, you have to calculate using v is equal to f lambda. Write the answer in your notebook. I will be checking. I'll be asking you to give me a photo of what you've solved today. So first thing first, the mark, I forgot to give you the marks, but basically formula is not given, so 1 mark for that, 1 mark for the conversion, and then 1 mark for the 1 mark for the conversion and solution. No, 1 mark for conversion, sorry, and then 1 mark for the working using v is equal to f lambda, and 1 mark for this, for the answer here. The meter per second will not be given a mark because it's already given in the blank. Usually when you're in year 9 and for a few months of year 10 they will be giving you this, but as you progress to year 11 and year 12 they won't be giving you this anymore. It's up to you. What are you solving, what quantities do you need to have, so you have to be mindful of that. Okay, and next, same thing here, you're going to solve this in your notebook also, so I'm hoping that you will do that. I need to see all of your answers to these questions. Do you understand? Okay, so this is just v is equal to f lambda, and you have to understand by now why marks are given this way. Okay, so that's it. Anyway, this question is easy. It's 440 hertz, so it's and 340 meter per second is quite direct. Directly it will be given to you. Okay, sorry about that. I don't know how to move on from this slide. I don't know how. Oh my god, where did it go? Okay, so that's it. I think I cannot show you the last 2 pages of this. I don't know how, but what did we learn today? So we learned how to use our knowledge. No, we used our knowledge of general wave properties to answer the questions and solve problems using v is equal to f lambda. I think there are a few more questions following this slide, but I don't know how to close it already, so this is the last page that I will be discussing. If there's another page following this, please solve it in your notebook. I'm sure it's only v is equal to f lambda. Okay, I hope you enjoyed this video. Tell me if you're bored, so I won't be doing this again. I'll be using another technique tomorrow if you're bored about listening and these kinds of videos and tutorials using videos. So that's it. This is what we learned today. It's about general wave characteristics still. So this is Miss Teresa signing off. I hope you enjoyed and have a nice day.